Right. So the introduction class was about RF and baseband. Baseband initially means the information processing part. Information processing. Right. RF or the term front end. Right. It is something like making ready for transmission. Making ready for transmitting, as well as the corresponding thing called receiving. Right. So why do we have such an idea? I made it clear because the front end is significant, right? Only in wireless systems. This is the first point that you have to note. Wired systems, there is actually nothing called as a front end, because baseband as it is, you can just coolly transport it. So there is nothing called as a front end for a wireless system. Wired system. So a wireless system has this front end, and in this wireless system, this front end interacts with atmosphere directly. With atmosphere or environment. Getting it? So there is a need for standardization. This was what we were doing in the first class. Clear? So there is a term called standardization. Lahari?
Yes, sir.
Lahari, we discussed this term. Front end has to be standardized. What was the problem if it was not standardized?
Like the common person won't understand what it is.
Give me an example.
Like as I said, with like the USB cable.
Good. That's okay. What is this idea of, because it interacts with the atmosphere, there is a need for standardization, and how is it commercially related to the common man who will get affected? Can you just give me an integrated scenario there? One example will work it out.
I don't know.
Okay, no problem. If different, for example, if you get a PC and your mouse is one port, keyboard is one port, some other device is another port, you will have to run around for ensuring compatibility. So unless otherwise the front end is standardized, things are very bad commercially. This I had discussed extensively during our transmission line course also. Right. So in this subject, you are going to see this idea of how they standardized. How they standardized. Clear? And a little bit on what are the standards. That's what I am trying to tell here. For example, during our waveguide interaction, I think I told you waveguides, they have a standard size. That's all. You cannot manufacture anything out of that size. So we are in this subject, slowly I'm trying to get into the subject. We are going to study the process by which the front end of wireless is standardized. Clear? So how they are standard, what are the parameters? What are the parameters that you should do? All these things we are going to see. Clear? So how to talk in terms of front end. Clear? So now, for example, if I want an amplifier for a receiver, so how should you talk little bit at a commercial level? That is what we are trying to do. We are not going to worried about, say, input impedance of the amplifier. We are worried. I am not telling we are not totally worried, but finally, after analyzing them, we are coming up with a new parameter, right? Those parameters are known to everyone among the industry. For example, there is something called as electronics. I think I have told this. If not, please note it. Electronics Industries Association, EIA standards. Right. So these guys, they will not talk in terms of input impedance, output impedance, H parameters, transfer gain, all those things. They have their own set of parameters, by which they will be communicating. So this is what slowly you are trying to understand in this subject, right? So what I am trying to tell is that's what when I completed the class in the last thing, I told you very clearly, we will deal about amplifier, but not as a circuit element. So we will be dealing everything as a black box, right? So at the front end level, so at front end, at this level, right? Every component will be treated as a black box. What do you mean by a black box? I will tell you. This is just an English term that I am using. In the sense, you will just tell that this is the component, right? You will just know what is the input and what is the output. Clear? You should know this. I am not telling we will not know this, but we are now going to derive some parameters. So this component can be, say, an amplifier, or it can be a transmission line, or it can be a filter, right? Whatever it can be, right? We will build a uniform parameter. We will build a uniform parameter, right? Whose name is scattering parameters. Yes, parameters, scattering parameter. This is the name, right? We will build a uniform parameter that will describe the functionality, right? We'll build a uniform parameter that will describe the functionality. Getting it? Right, which leads us to the first topic, which is called as what is the idea of S matrix. Still, I'm not going to get inside it. I'm just trying to give you. So in this subject, what we are trying to do is whether it is an amplifier, whether it is a transmission line, whether it is a filter, whatever it is, you are going to study it as a simple black box. Right now, you should have understood what I am calling it as a black box. I am not worried whether it is a amplification process or a filtering process. I just want to know what is the input and what is the output. I want to know its functionality, and I am going to represent that functionality using a scattering single unified parameter. Right. So this Electronics Industries Association, when you are dealing with the front end, they said all you need to know is just this S matrix that determines the functionality of the device. Am I making my idea clear? This is what you are trying to study in this subject. Once you study this S matrix, then we will attack the same amplifier through an S matrix representation. We will attack a transmission line through S matrix representation. If you are able to get the S matrix of the transmission line, then you are able to talk in terms of front end. Getting it? Is anybody having any doubts or clarifications? Saurabh? 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 Saurabh is not there. Jayhari? Jayhari?
Yes, sir.
Jayhari, am I making my idea clear?
Yes, understood, sir.
Do you understand why we are building a uniform parameter, but that will describe whatever be the component? Are you able to get it?
Yes, sir.
Right. Okay. Thank you, Jayhari. So for the entire class, this is what the more crux of the introductory first chapter is all about. How to build this mathematical idea of S matrix. It may be a bit mathematical, but once when you understand it correctly, you will have this idea beautifully. Getting the idea? Anybody wants any clarification on this? So talking in terms of S matrix, simply now I am just diluting the definition of RF engineer. An RF engineer should talk in terms of S matrix. That's all. A baseband engineer, clear? A baseband engineer will talk in terms of coding, demodulation, or if he is in the hardware part of the baseband, he will talk about gain, input impedance, all those things. For us, we will analyze all these things. Clear? but finally the output or the conclusion of our analysis will be a simple S matrix. Right? Now, this idea is what the basic takeaway from today's class. Clear? So don't think that we are not going to study electronics. You need all the concepts, but after that, finally, we'll take it as a black box. Clear? When you are selling an amplifier for the RF front end, you should have its S matrix in place. If you are selling an amplifier for the baseband processing, clear? Then you need the gain, input impedance, HFE, whatever you want, you tell. Right? You will need it. For us, it is only S matrix. Right? Now, why this idea? This we will see. Why this, what to say, why this subject or study, or why they created like this? Why just subject study? Clear? The same transmission line, the same amplifier, right? Why should we create this thing, and what is it that makes this front end a bit more serious? Right? This I had this is just a qualitative explanation to reinforce the fact that you need this subject. Clear? Because when you go outside, probably you will be talking only in terms baseband. Things are all hidden inside. Clear? Right? Who can now? I'm just Abhishek 215. Abhishek. G Abhishek.
Yes, sir.
Abhishek, we have our mobile phone now, Abhishek, correct?
Yes, yes, sir.
What is the technological name to the mobile phone that we are operating? Most of us are operating 99% in India. They call something as GSM, no? What is it?
I'm
GSM.
sorry, sir.
You don't get it.
I'm not sure, sir.
You're not sure. Can anybody tell me what is this? The mobile phone in your hand. Thank you, Abhishek. Thank you. The mobile phone in your hand, it is called as a GSM handset. At a very technological level. A mobile common man, you or me, we can call it as a mobile phone. But the idea is it is a GSM handset. GSM there stands for the technology of the front end used there. That front end is called GSM. You have another phone called CDMA phone, which is not that much popular in India. Right. Now, even if a company tries to sell CDMA, they will face difficulty. Reliance, actually, if you look at the history of their Jio Telecom, Reliance started off with CDMA based phones, but things didn't work out because 99% of the population was having a GSM handset. Clear? Now, what are they trying to tell by 5G, 5G, 5G? If you want to implement 5G, 90% of the population should change their mobile handset. That is why 5G implementation is getting delayed. 4G implementation never had any issues because the moment they created any phone greater than 1G, that phone was okay for till 4G. Right, the front end antenna, the front end amplifiers, clear, both the transmitting and the receiving part. Now for a 5G, the frequencies are different. Once the frequencies are different, the hardware has to change. Hardware has to change means the mobile phone has to change. So that is why big talks are going on with 5G, 5G, 5G. Nobody's trying to give it out fully. Unless otherwise you have a 5G handset in your hand, there is no meaning. Clear? So from that angle is what we are trying to discuss this subject. We will have a bit of theory, but if you are not comfortable with this commercial look, right, the subject will be really dry. We will be simply talking about S matrix, things will be boring. Clear? Specifically, since we are not in the direct contact mode, I am very much, see, my idea is even if you learn only 10% of the subject, you are okay with that entire 10%, I am happy. There is no meaning in going ahead without knowing things. Clear? So does anybody have anything to clarify or anything? Any doubts? Please do come up with it. Any doubts? Anybody wants to clarify anything or? I am ready for discussion. Yeah, please. Who's it?
Sir, this is Sriram, sir.
Yeah, please.
About the question, the question you asked about transmission lines.
Yeah.
Whether it's baseband or. Can you answer that? Because there is also the waveguides component.
Yeah.
And you said like it's a wireless system, then there will be a front end, and if there's a front end, there's a chance that it's RF, right?
Yeah.
So what's the answer for the
Yeah, I'll come to it. Thank you for reminding it. If you are working in a transmission line manufacturing company or in a waveguide manufacturing company, precisely, let us first have it. We are working in V-guard cables. Transmission line is a component that is now used both in baseband as well as in RF. Clear? The specifications may change. Now, what is called as RF and baseband? Do you understand correctly? In fact, amplifier also is used in baseband, also in RF. Getting me? Shriram?
Yes, sir. Yes, sir.
So my questions were all actually, we started off with an app making company. Slowly in that way we went. Suddenly I went into a component company, correct?
Yes, sir.
So when it is a component, fundamentally, if you are working in a filter company, you should first of all have an idea whether my filter is part of the front end or it is part of the baseband. Clear? So simple. For example, it is working at the carrier frequency level. You call it more at the RF front. If you are just worried about image filtering, you have a sound message that has been decoded and you are worried about filtering, you are worried about designing that filter, you are at baseband level. Getting the idea? So the moment it comes to components level, there is no big differentiation. The company has to tell that we specialize in these things. Shriram, am I making it clear?
Yes, sir. So there's a possibility it's both, right?
It's not see, that question itself was, I just put it for an academic purpose only. So if you go to V-Guard, for example, V-Guard cables, it is there in Coimbatore, okay? Just opposite our campus. They are fundamentally a base manufacturing cables for baseband applications only. They are not manufacturing cables for the front end applications. Getting it?
Yes, sir.
That's all. That V-Guard has to specify in its own thing. The main issue is in India, we all specialize in app making. So fundamentally, you are working only in information processing. You are not at all. For example, you create an app assuming that the front end is available. What is the front end? Mobile phone. So that front end is standardized there. You are only putting an app on that phone. You are least worried about what is the front end, correct? So that is what I am trying to put across here. The moment it comes to component, it's quite difficult to identify. The company has to tell that what area I am working. Is it okay?
Yes, sir. Thank you, sir.
Thank you. Is the answer clear?
Yes, sir. Yes. Thank you, sir.
Okay, great. Anybody else has anything else to ask?
Sir.
Yeah, please.
So that app development will come in baseband, and then front end mobile phone will come in RF because it is standardized. It says so, sir.
Yeah, definitely. Mobile phone has to be standardized. The antenna has to work in the GSM band, 969 megahertz.
Okay, sir.
Clear. If you don't manufacture it, then your phone won't work. Correct?
Yes, sir.
Getting it?
Yes, sir. Yes, sir.
And you understood relation to 5G also. If everybody, Airtel wants to roll out 5G, first of all, everybody should go to 5G handset. Getting it?
Yes, sir. Yes.
If I don't have the 5G handset in my home, in my hand, what is the use in having a 5G tower? Getting it?
Yes, sir. Okay, sir.
Because the 5G, little bit the frequencies are different, the filtering standards are different. Clear?
Okay, sir. Yes, sir.
Anything else? I would like to have discussion. See, because in this subject, it is bit at a commercial level only. And as a BTech student, you should be able to relate whatever we studied in second year, third year to the real world. The only thing is the parameters in real world will be called differently. Right? Even if you go to a mobile phone tower and you should not ask what is the S matrix of this cable and all. Please don't do those things and all. There, they will go into still commercial terms. S matrix is just the starting from, for example, transmission line, you had characteristic impedance, propagation constant, phase velocity, these things and all. From that towards commercial level, we combined all these things into one single thing. That is called S matrix. Now, if you go to real field level applications, they have something else. They have codes. For example, have you heard of this thing, RJ45 cable? Can anybody tell me what is this cable? RJ45, RG8.
Sir, is it an Ethernet cable?
Exactly. This is that LAN, so-called LAN cable. Right. Now, this is still commercialized from the S matrix side. Getting it? Now, they will not even talk about S matrix there. So, there is some RJ45 depending on the mechanical manufacturing of that front end connector. Right. RG8 cables are standard audio cables. So now my fundamental aim is this idea of theory and practical. You should try to slowly create a link. Right. So this is what actually I am really happy that you guys gave a good discussion here and really helped me. So what we had as high-end theoretical concepts and mathematics, right? Through S matrix, we will slightly go into commercial domain, right? S matrix, there are another things called signal flow graphs. There are another things called ABCD matrix. Lots of things are there. Many matrix representations are there, right? But all these things are just taking us towards commercial level, commercial definitions, right? From this comes RJ45, all those things. RJ45 in the Murray cables along. So that is why you should. That is why people tell that no engineers, persons graduating from BTech ECE knows what is characteristic impedance. Characteristic impedance is talked at this level. If you ask him phase velocity, this is all at this level. Gain, the line, right? This is our RF engineering subject. This I will call it as 15 ECE 402. Right? This is the domain in which you are working. That's all. Wherever you go and get placed, there you will know what are the commercial domains. It is your duty to come back there actually. I would like to put it there. Once you get job in the domain, you should come back and see that these things are happening. Clear? So this is what we are now worried about. Anyway, having started like this, who can tell me what is the issue behind US and China in 5G? US, China. What is the idea of 5G war? Can anybody, because it is.
Sir, in US, they were actually trying to replace the devices which are already present, but China had actually brought up a plan like using the current devices, they could actually bring 5G.
Who was it? Who is it actually? See, since I don't know I am worried in that word file. I'm not able to see who is answering. Who is it?
Sir, Vinil, sir.
Vinil, good. Who can give a technological aspect to it? Vinil gave it in a real commercial domain. If you are answering to government officers, you can answer like this. But at an academic level, in a university level, what can you tell? Who has gone in depth into it? This is the fundamental idea that is going on now. Whole world, will it buy US technology or China technology on 5G? That is what Vinil said. So the idea is US developed its 5G in the frequency 24 to 26 gigahertz. Right? China put it under 6 gigahertz. That is somewhere in the 4 to 6 gigahertz. Getting it? Both implemented the 5G. For example, see 5G, first of all, you should know what is 5G. Rahul.
Yes, sir.
Rahul, when Airtel says I am going to give you 5G connection, what are they actually telling?
Improving transmission rate, sir.
Improving transmission rate. Okay, so we can decide that for a common man it is high speed, correct?
Yes, sir.
That's all. Thank you. So thank you, Rahul. So finally, 5G means better data rate, big transmission rates. Now the problem is China got it under using 6 gigahertz frequency, whereas US developed it in the 24 to 26 gigahertz. Who can now tell me this was what I was telling? So now if you adopt US technology, you have to change the handset. If you adopt China technology, you don't need to change the handset. Getting it? Because our present GSM handset, which each one of you are having, even I am having, okay, don't worry. GSM handset can work in this domain. Right? It cannot work in this 24 to 26 gigahertz. This is what the main politics that is going on. Clear? And to give you the extra masala, India, if it adopts US technology, China is gone. No, see, India is the biggest market. So if India decides to go along with China or US, whatever is our decision, that will affect or the future development of real 5G. This is what the real politics that is going on. Getting it? So as EC engineers, you should be really careful of this thing, right? Let us leave out all the politics and all. If India decides to adopt 5G, huge change. The common man, okay, let me put it there. You should understand this actually. Right?
Excuse me, sir.
Yeah, tell me, yeah.
Sir, so then if it's possible to, implement 5G with the present handset, why is, I mean, there must be some advantages to use this method also, right? Because everyone will prefer the China's method because they don't have any extra cost.
Yeah. But that is the issue, no? But everybody wants to avoid China also.
Okay.
You can't do that.
Yes, sir. Okay.
Right. So that's what I'm happy that you guys bring it there. So if you take US technology, right, common man has to change. This is a big problem. Common man to change handset. This will not happen so easily. Common man to change handset. Right. Big change at tower infrastructure. Big change in tower infrastructure. Right, the amplifiers, the antennas, everything there. Clear. Compared to this, so this involves heavy cost actually. Right, this means real heavy investment. Right, whereas if you go for the China issue, the biggest advantage is common man needn't change. Simple. Common man needn't change. That is the beauty that he has brought into it. We can't do anything there. Okay, we can't avoid him. Right, and there is only a small investment in tower. Small investment in tower. So he has brought out the technology like that. You don't need to go to the common man. The tower, some small modifications and you can get it. So naturally, any company, what will they do? Any, for example, at a government level, what will they do? They will prefer only Chinese handsets. Right, but India has still not finalized. World is angry at China over the coronavirus thing and all. So we are not yet decided. But US has rolled it out in their own thing. China has rolled it out in their own thing. But everybody is waiting what India will do. 1.4 billion, nearly 1 billion hands users. Where will they go? Right. So if you want to read the news items regarding these things at a commercial level, you can read. Little bit it comes into these things. So the company that are involved in these things are, for example, here Qualcomm is betting on it in US thing. Here it is our usual people, ZTE. I don't know, I'm writing the spelling correctly, Huawei and all those guys. These guys have equipment ready. You just need to call them, they will come and fix it. Right, such is their technology. Clear. Right, so that is the idea there. This is the problem of front end. Clear, I am discussing this problem intensively because you have to understand it correctly. Right, now let me give you another thing. For example, in railway stations, I think Google is giving some free Wi-Fi, no? RailTel or something is there. How many of you have experienced it? RailTel, right? Where you get free Wi-Fi, right? This is something developed by Google. What they did is clear. They had a combination of, see, they're actually, what to say, there is a user. Clear, there is a Google equipment. Right, and then to the common infra. Right, here they talk in the GSM mode, but here, since Google is not a licensed user, what do you mean by a licensed user? Can anybody tell me? because Google has to take your data. He's giving you connectivity there, right? So what do you mean by a licensed user? Can anybody tell me who is a licensed user? Prakalya, Samukta, anybody?
Sir, no idea, sir.
No idea. Right.
Same, sir, no ideas.
No idea. See, the licensed user means Airtel, Jio, these guys are all licensed users. They have all got frequencies here and they can communicate. Google, since he is not a licensed user, Google not allowed to use GSM band. So he went into low frequency. That is the beauty there. Low frequency around 300 megahertz. Here there is no license there. Clear. So and then he does some activity there, something that he does and he gets connectivity. So he has this Google equipment, right? Some conversion logic, right? Then he connects to the to his satellites and gets it done. That is how it is being done. That is why he's able to give you free. Clear, because there is only small investment cost here. He has found out this technology there. So it is a combination of, if you ask me whether it is a baseband or an RF, the question doesn't come into picture here. He has used both and given you the service there. Right, this is how we are able to get free Wi-Fi and all. See, how are they able to give you free? Because the operation cost must be very low. So Google has their own satellites and all those things they have. Only thing is how to get the data across. So I'm not telling too much into this. There is this Google Balloon project and all. If you go and look into it, you will get a fairly good idea. Balloon project, Google Loon or something. Facebook has also got a project by which they are trying to give you connectivity. Right? Connectivity means front end, but these guys are not registered players. So how are they doing it? Clear. It's actually an interesting thing. Facebook and Google have their own balloons wandering in the upper atmosphere and giving you connectivity, but these guys are not registered. Facebook is not like Airtel or Jio. But how do they do it? Then it's a combination of RF and baseband. Getting it? Right. So try to understand these things. This is what is called as front end. My main aim in discussing this thing is to create interest. Clear, and you should understand why we are not talking VLSI, electromagnetics, all these things in public domain, because common man won't understand. Common man has to be given devices in the language he understands. Clear. So I'm requesting you please go and search for this Facebook project, Google Balloon project, right? Try to see RF and baseband there. Clear. The clear cut definition may not be there, but you should know how things are going to develop in the future world, right? So we'll slowly stop the class here because I think it is 9:37. Any doubts in today's class? In fact, sorry, I didn't get into the idea S matrix. I stopped there. But anyway, having an idea of applications is always good. Any clarifications or anything with today's class? Or anybody wants to discuss something? I'm ready.
Sir?
Yeah, who's that? Please identify, okay? Because I'd like to know who's asking. Yeah, tell me, Varsha.
Sir, with only 300 megahertz, how is it possible to connect to a satellite? Because you need high frequency, no, sir.
I understood that, ma. See, Varsha, I didn't. Okay, I'll tell you. Because I didn't give you the full idea there. They have a conversion logic, and in here, no, in this point, are you able to see this word file? In this point, the circle I have drawn?
Yes, sir.
They have their own technologies, ma. Maybe not through satellites, through ground-based fiber optics also it is there. Okay. They have their own networks here, which nobody will object to. If you are ready to put a network, nobody will object to. But you can't operate the frequencies that Airtel, Jio, and these guys are operating. Getting it? In fact, this box, I need to explain more. I just wanted to tell you that Google, Facebook, all these people, they are into combining these things and breaking the traditional definitions also. Getting me?
Yes, sir.
Because with your mobile phone, what is the Wi-Fi frequency? For example, if you are walking in college, 2.45 gigahertz. Okay. Getting me? Varsha, are you there?
Yes, sir.
That is the Wi-Fi frequency which you are doing, and your mobile phone is also comfortable with it because it is manufactured for that. Getting me? Right? Now, Google is coming with this free concept. So finally, it will connect with your device at 2.45 gigahertz. But then if Google has to transmit the data using Airtel or Jio, then he has to pay them. Correct? Correct, ma?
Yes, sir.
Now, if he is paying them, then can he give you free?
No, sir. That'd
No.
be expensive.
He has to recover that expense somewhere, no? Correct. Clear. So I'm just trying to bring out this concept of free Wi-Fi. These Google guys, what they did is they created their own hardware and tapped the fiber optics based thing, and somehow they avoided the cost of transporting things. More has to be. That's why I told you, if possible, please go and search for this Google Balloon project, Facebook project. Facebook has got this project of providing connectivity. Finally, what are these guys doing? Giving you connectivity. Clear. So that is what I am trying to tell. More has to be looked into it. Right? They are combining the. When I started the subject, I told you this is baseband, this is RF front end. This works like this works like this is communicating, all these things. We had a standard literature. Okay, and that is what you are going to study also. But these new companies, what they are doing is, this is called as disruptive technology. Clear, this is what they are calling it as disruptive technologies, and they are trying to bring in new things. If this becomes famous in 10 years, our subject will go away. Getting it?
Excuse me, sir.
Yep, tell me.
Sir, when it comes to these companies like Google and Facebook, what's stopping them from actually getting a license? Because recently, like what you're saying, the Google Balloons and Internet.org by Facebook, both of them have been scrapped, sir, because they couldn't achieve costs that were sustainable enough for them to give free.
Yes, so, it was a project. It was only a project there, actually. Yeah.
So essentially, when it comes to Google and Facebook, they're essentially companies that sell ads. They sell their products for free anyway.
Yeah.
So why can't they just get a license and then get going? Because they know how to sell things. So I don't see why they have to come up with ideas that have low costs or
Got it. See, the idea is this license has been traditionally held by, for example, in India, BSNL, Airtel, Jio, China, ZTE, Europe, you go, Euros. And there are some established companies, the old telecom companies, correct?
Yes, sir.
Hearing me? Yeah. Okay.
Yes,
so now if Google and Facebook wants to enter it, there are some rules that you have to give proper communication and all those things. You have to establish a vast network there. You have to give phone service, everything. Simply just like that, you can't become a license provider. Okay. So my personal opinion is Google saw that there is no meaning in entering into that business as per. That's why Facebook tried to enter into an agreement with Jio. I hope you read that news. Facebook tried to enter into an agreement with Jio. Nothing has come out of it. Right. So this final telecom or those companies, if you want to get a license, there is a very huge infrastructure that you have to commit. I'm using the word commit. And little bit it is linked to the government security also. Able to get me, Narendra?
Yes, sir.
So these people are not worried about. So they are telling that we will have our own way. You don't worry. We will provide our own connectivity, but they are keeping on experimenting such that they can optimize their costs. Getting it? It will not come out in one fine day and all. No. Okay. This is what I have to. I have inferred. Okay, Narendra.
Okay, sir.
Okay. This is not a final answer. This is my inference. Getting it? At present, they are not invested in committing such for that entire industry. They are creating their own path actually, in which there may be some failures here and there and all. But I think they will go ahead. They will get it. That's what they are. That's why they are called as disruptive technologies, right? Because they disrupt the existing scenario. Right now you'd have got an idea of what is that disruption. Getting me?
Yes, sir.
Yeah, that is my present idea. It's only a discussion topic. There is no right and wrong here. Okay. Anything else, guys? If nothing else, thank you. We'll stop the class, right? The notes will be uploaded and you can leave. The class is officially closed. You can leave. Thank you. Anybody has any doubt, you can please ask me. I'm stopping recording here. Yeah. Guys, thank you guys. The class is officially closed. Anybody with doubts can stay, others can go. You can go to the next class.
Thank you, sir.